It's May 6, 2026. Here's your space and science briefing. JWST has directly examined the surface of a distant exoplanet for the first time. Astronomers use the James Webb Space Telescope to analyze light from a rocky exoplanet and determine its surface properties. The world registers as a dark, hot rock, providing the first concrete data on an exoplanet exterior rather than just its atmosphere or orbit. This marks the first data set to examine an exoplanet exterior directly rather than inferring only atmosphere or orbit. The captured emitted and reflected light reveals a dark, hot surface with measurable thermal properties. It shows the telescope's expanding ability to characterize solid surfaces on distant rocky worlds. This breakthrough opens new ways to understand what these remote planets are actually made of. The James Webb Space Telescope has achieved the first direct study of an exoplanet's surface by capturing and analyzing its emitted and reflected light. Previous observations could only infer bulk properties or atmospheric composition. But this dataset reveals the world as a dark, hot rock with measurable thermal characteristics. The result demonstrates the telescope's ability to move beyond transit spectroscopy and examine solid surfaces on distant rocky worlds. Future targets may show whether such planets share common surface minerals or retain unexpected features shaped by their formation histories. How many more rocky exoplanets will yield usable surface data before the telescope's instruments reach their limits? From the first clear view of a distant rocky surface, we move to a world much closer that nearly escaped detection entirely. A planet with Earth-like traits has been confirmed in a nearby system after earlier observations missed its subtle signals. The confirmation came after subtle signals were finally detected in data from prior surveys. Its potential habitability elevates it as a priority target for atmospheric follow-up studies. The planet's Earth-like traits make it stand out among other nearby discoveries. This raises the stakes for future observations that could examine its atmosphere in detail. The fact that it was nearly overlooked shows how challenging these detections remain even with advanced instruments. Now that it is confirmed, astronomers can focus resources on understanding whether conditions there might support life. While we refine our picture of nearby potentially habitable worlds, solar activity is quietly reshaping the environment much closer to home. 36 years of tracking data show that orbital debris begins falling much faster when solar activity reaches roughly 67% of cycle maximum. The data come from long-term monitoring of how the sun affects objects in low Earth orbit. Once that threshold is crossed, drag forces pull debris down at an accelerated rate. The result improves predictions for when satellites and debris will naturally deorbit. Better forecasts mean operators can plan maneuvers with greater confidence. This connection between solar cycles and orbital decay helps reduce the risk of unexpected collisions in crowded space. As the sun influences how quickly objects fall from orbit, another satellite mission is learning to separate what is happening on the ground from what the sun itself is doing overhead. You know what's fascinating about this? If the sun were scaled to the size of a basketball, the thermosphere would still extend hundreds of kilometers outward during peak activity. That is enough to reach satellites that normally orbit in near vacuum. Picture yourself riding alongside a spent rocket stage at 400 kilometers altitude as a surge in solar ultraviolet radiation heats the thin air below. The air balloons upward and creates measurable friction on every pass. Over 36 years of records, researchers identified a clear threshold at roughly 67% of cycle maximum. Drag forces then shorten orbital lifetimes dramatically. This process can lower a satellite's altitude by tens of kilometers within weeks, far faster than gravitational perturbations or residual atmospheric density at solar minimum. The same expansion also increases collision risk for active spacecraft that must fire thrusters more often to stay in position. Yet the precise chain of energy transfer from solar photons to atmospheric molecules to macroscopic drag still contains gaps that models cannot fully close. ESA's Swarm constellation is now distinguishing faint ground hazard signatures from stronger disturbances caused by solar storms in the upper atmosphere. The three satellites work together to separate these signals with greater precision. Better separation helps protect power grids and communication systems during geomagnetic activity. Ground events that might otherwise be masked can now be identified more reliably. The constellation's measurements improve real-time awareness of hazards that affect infrastructure on Earth. This capability turns existing satellite data into a practical tool for daily operations and emergency planning. From protecting infrastructure here on Earth, we turn to a visitor from the outer solar system that had just survived a close encounter with the Sun. Comet C/2025 R3 Pan-STARRS survived its perihelion and is now visible in the evening sky for Southern Hemisphere observers. An 11-minute LRGB exposure taken with a 12-inch telescope captured the comet as its brightness continues to fade. The survival of the comet after such a close solar pass is notable in itself. Southern Hemisphere observers have a window to catch it before it fades further. The images show the comet's tail and nucleus responding to the intense heating it endured. While one comet is fading in southern skies, another annual shower is peaking right now under challenging moonlight conditions. The annual Eta Aquariid shower reaches maximum this morning, though a gibbous moon will reduce visibility for most observers. Early risers in clear, mild conditions may still spot meteors radiating from Aquarius. The shower is known for producing swift meteors that can be bright even in less than ideal skies. The moonlight will wash out fainter streaks, but brighter ones could still appear. This annual event offers a reminder that meteor observing requires patience and the right timing. From fictional journeys built on real science, we close with fresh satellite views of an ongoing natural event right here on our own planet. The European Space Agency is collaborating with French studio Don Tinaud Entertainment on the narrative science fiction title Aphelion. Real planetary science and exploration concepts will shape the story of a journey to the fictional planet Persephone. The partnership brings authentic details about planetary environments into the game's narrative. Players will encounter situations grounded in current understanding of distant worlds. This approach turns entertainment into an indirect way of sharing how exploration missions actually work. Persistent activity at Russia's Shiveluch volcano continues to melt snow cover on its flanks. Satellite views document the latest phase of this long-running eruption in the Kamchatka Peninsula. The images show ongoing changes to the landscape as heat from the volcano interacts with seasonal snow. This kind of monitoring helps track how eruptions evolve over months and years. NASA images provide a clear record of the snowmelt that might otherwise go unnoticed from the ground. That covers the main developments from today's space and astronomy news. Keep an eye on upcoming observations of the newly confirmed nearby planet as atmospheric studies get underway. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. This podcast is curated by Patrick, but generated using AI voice synthesis of my voice. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy, and I hope others do as well.